Greetings, mathematicians. Time for our next set of notes from Module 2. Now don't worry, I have not forgotten. Like you, I am going to put my name and number in the corner here, but thought I'd mix it up today. Start with Module 2 notes right there before getting my name and number on that paper. Let's zoom in a bit, now that we have our name and number there, and talk about our lesson. Now, this is Lesson 2-8, Module 2, Lesson 8. Today, after working with models and doing some other things, today we're going to practice multiplying with the standard algorithm. You have done this before. The algorithm itself is not new. Eventually, we will start talking about decimal points and how that factors in, but for right now, not even going to mess with that. The only way this will probably be different than your 4th grade multiplication is that our numbers are going to be a bit bigger. So there is our Roman numeral 8. We've got a 5 with 3 ones, so 3 more than 5. Not going to make time for vocabulary today. Some of what we're going to do is going to take up a good chunk of the page, and really we've talked about the important vocabulary words. Hopefully you remember what a factor is. Factors are the numbers that are being multiplied together. Hopefully you remember what a product is. The product is the answer to a multiplication problem. Okay. And you also hopefully remember what I'm about to talk about with step 1. Hopefully you remember what it means to estimate. Now we've spent a lot of time talking about estimating this year. Estimating when you are doing problems like this is so that you can check and make sure that your final answer is reasonable. Okay. Whoops. Let's make sure I spell use correctly, shall we? Use later to check reasonableness. If an answer is reasonable, slide that over, reasonableness. If an answer is reasonable, that means it looks like it could be right. It should be close to the estimate. Now, an estimate is not going to tell us for sure yes or no if our work is correct. But if our estimate ends up being close to what we get when we use the standard algorithm, we can feel pretty good that our answer is probably right. Now, step 1, as always, we zoom in, we zoom out. Let's say I give you a problem that looks like this. 149 times 312. 149 times 312. Going back to what we've talked about with our rounding, 149. Now I could round this a couple of different ways. Okay, 149, if I round to the greatest place, it's going to be 100. But man, 49, that's a weird one. That is practically 50. Which means, really, is this closer to 200? No, but this is a weird number. So I'm going to do something weird. Instead of rounding to the nearest 100, I'm going to round to the nearest 10. To the nearest 10. So 149 is about equal to 150. If you're more comfortable rounding to 100, just do that. 312, that's a bit more normal. I can just do times 300. Looking at this, 3 times 15 is 45. 1, 2, 3 zeros, 1, 2, 3 zeros. So my estimate is 45,000. Hopefully my final answer will be somewhere in the neighborhood of 45,000. Let's find out. Step number 2. We're doing standard algorithm, and whenever we do standard algorithm, one of the earliest things I want you to do is write vertically. You're going to write the factors vertically. Okay. For the standard algorithm, when we're adding, when we're subtracting, we want to write everything up and down. I've heard some of you refer to this as stacking the numbers. Stack them up. Now, we want to line these numbers up on the right. So I will say the right side, but really what we're doing is we're lining up their place values. We're lining up the ones place. Commutative property says I can put them in any order I want. I'm usually going to put the longer number on top. Now this is 1, 2, 3 digits, 1, 2, 3 digits. They're both the same length. This one is a bit bigger though, so maybe I'll put that one on top. Again, it really honestly does not matter. Not with multiplication anyway. Multiplication's like addition. Nice and relaxed. We'll go ahead and put the other one on the bottom, and like I mentioned earlier, we're lining everything up on the right. Line the numbers up on the right. This will become even more important once decimals get thrown into the mix, because we spent so much time trying to line up decimals, but with multiplication we don't have to do that anymore. We line everything up on the right. And in that case, it won't even be the ones place. It'll be who knows. But as usual, I'm getting ahead of myself. Let's deal with this for right now. Okay? Line up all the numbers on the right. If this had been 1,312, the 2 and the 9 still would have been lined up this way. Okay? I mentioned this earlier, but we'll go ahead and write it down. Longer, or if there is no number that's longer, if there's one that's just bigger. The longer or bigger number on top may be easier. Again, everybody's different, and there's no rule that says you have to do it this way, but I strongly suggest it. Longer does not mean greater, though. Sometimes it is, sometimes it isn't, but thanks to decimals, it's not always going to be true anymore. If it has more digits, if it has 4 digits, 5 digits, 6 digits, put it on the top. You'll see why in a moment. Step 3. Okay. Now I'm going to do the best I can to make this very clear, but the way I explain it might be difficult, or different. Ooh, I hope it's not difficult. It may be different than you've heard it before. Okay. Circle the bottom, thank you pencil, circle the bottom right digit for your, we're going to call this the focus. Now this is not necessarily a classic math term, this is just something that I use to help me and hopefully to help you. We're going to circle a digit, the bottom right digit, to be our focus. Starting on the right, I know we got a lot of writing here. Starting on the right, multiply the focus by 1 place at a time. What we're doing is connected to the area model. We're multiplying one piece times each place value, each column. Okay. I'll be able to show you that a bit better in a moment. You are going to regroup and repeat as needed. And I'll show you what I mean by that, because we will need to do both for this particular problem. Okay, let me slide this up so we have plenty of space. I'll copy down from up above. You can't see it on the screen right now, but you have it on your paper. 312 times 149. I am going to find the bottom right digit. So the very bottom, the right. This is going to be my focus. 9 times 2. I start going straight up. 9 times 2 is 18. Now, I cannot put that down here. I cannot put the 1 down here. It's one group of 10, so it needs to go over to the tens column. It needs to go over here. Now, imagine the 9 is looking straight up. It's going to click itself over, and now it's going to look over here at this column. 9 times 1. Well, 9 times 1 is 9. Plus the 1, now it's 10, so I have the same issue. I cannot write 10 down below, so I have to carry the 1 up here. Now I keep saying 1, I will say that often, but what's really happening is I just multiplied 9 times 10. Remember, this is in the tens place, 110. 9 times 10 was 90. Then I added another 10 to it, so that was 100. The area model breaks this up and makes it a lot easier to see. But the area model's long, which is why we usually do it this way. 9 times 3, 9 times 300. 9 times 3 is going to be 27. Plus 1 is 28. Now there's nothing else over here, so I can just stretch that 2 out in the next column. At this point, I am done with the 9 as my focus. I'm going to shade it in lightly just to show that I'm done. I'm going to shade these in too, just in case I need to put anything else up there. I am not blacking it out. I am not grinding it into dark nothingness. I am not erasing it. I'm just making a light note so I know that I'm finished with it for now. Now, once I get down here, when I go on to my new focus and I'm multiplying by 4, this is not really 4. This is really 40 because it's in the tens column. Now, to make sure that I keep it lined up in the tens column, I put a spacer 0 right here. This is one of those times where graph paper is super helpful. I put a 0 in this column to show that I'm multiplying by not just 4, but 40. Can you see that? 40 times 2 would be 80. Now from this point on, it gets a little cumbersome if I try to say 40 times 10 and so on and so forth. So I'll just, again, go back. I did 4 times 2 was 8. Spacer 0 is here because I want that 8 in the tens column. 4, click, times 1 is 4. 4, click, times 3. 4 times 3 is 12. Didn't have any regrouping that time. This 1, I mean, again, there's nothing over here, so it just drops down. Okay? Once again, lightly shade that out to show that I'm done. Go down to the next line. I am not multiplying everything by 1. I am multiplying it by 100. So I need more spacer zeros. I need 2 spacer zeros this time. Every time you move to a new focus in a new column, you're adding a 0. So this got 1 0. That got 2 zeros. If I had another thing, I would put 1, 2, 3 zeros. Thankfully, this is all we're doing right now. But again, please remember, when you go to another focus, when you go to another column, add spacer 0 or zeros. Okay. There's 1 right there. And there's 2 more for that line. Okay, down to it. 1 times 2 is 2. Really, it's 100 times 2. That's why I have 200 here. 1 times 1 is 1. 1 times 3 is 3. Well, that was pleasantly easy. So it is time for us, we're going to skip 2 lines, 1, 2. It's time for us to talk about step 4, which a lot of you, I think, already know. You are going to add to get a final product. And after you are finished with that, that is not the end. A lot of students want it to be the end, but I'm sorry, 'tis not. Add to get a final product, and then, mechanical pencils, then compare to your estimate. Remember, we did that at the very beginning, almost 15 minutes ago, so that we would be able to use it right now. So I'm going to go up here. Don't worry, I'm not going to make you copy the whole thing again. We're out of paper. We are going to add to get an answer right here that hopefully will be close to our estimate. So 8 plus nothing is just 8. 0 plus 8 plus 0 is 8 again. 8 plus, I'm going to use the associative property and make a 10 because my goodness do I love making 10s. 8 plus 2 is 10, plus 4 is 14. I changed the way I matched them up, but otherwise added exactly the same. 2 plus 4 is 6. 6 plus 8 would also be 14. 8 plus 4 is 12. 12 plus 2 is 14. You get it. 1 plus 2 is 3. 4, 5, 6. 1 plus 3 is 4. Okay. 1, 2, 3 makes 1 period. So the answer I'm getting so far is 46,488. Okay. I have to ask, is this reasonable? Is this reasonable? Does this look like it could be correct? I ask myself a second question, although I guess it's kind of the same question. Is 46,488, that right there, is that close? And this is the key. It will never be exact. It just has to be close to our estimate. Is this close to our estimate of 45,000? And you know what? I'm going to make this even more obvious. I'm going to scoot it over a little bit and write it right underneath. Remember, the estimate was 45,000. Gives me an excuse to draw another arrow, and you folks know how much I love that. Would you say that these two are close? 46,488, 45,000. I hope that you're at home giving a fairly emphatic, a fairly excited yes, because they are very close to one another. Now again, they're not perfect. That's okay. They're never going to be perfect. That's just not how estimating works. But they're only off by 1,000. 1,488. They're pretty doggone close. If you had estimated the way that I taught you to, which I know I hate going back on that, but that's estimation for you. If you had just rounded 149 down to 100, you would have ended up with an estimate that was far, far smaller. You would have ended up with 30,000. 30,000 would be close enough. It would have been a 5-digit number. It would have been only about 10, 15,000 off. That sounds like a lot, but really, realistically speaking, it's not. You're looking for, is my answer 46,488 when my estimate was 12? Okay, if you're off by tens of thousands, then you know that something has gone wrong. But we'll practice that more in class. Sorry folks, this was another long one, but at least hopefully most of it was familiar. We'll stop here, but next time I see you, you can plan on more multi-digit multiplication with the standard algorithm. But for now, we're all set. Thank you, and have a pleasant afternoon/evening.